Welcome to another sharing session today. So we will go for a second question for indices question. If you missed the previous video, you can check out the one that we just shared earlier. So that was on the applying the law of indices into a few variations that we try and give you. So for the second question here, we are doing a solving for indices. Now, how many of you here took A math for yourself? Okay, and if you take A math, some of the students might be very used to using logarithms, right, to try and solve these questions. Now, because typically in E math students they don't learn logarithms. So if you use logarithms, you are taking a risk because it doesn't follow the basic answer scheme found in the answer key. So your teacher will try to find some way to give you the mark, but best is you will follow the best practice, which is to apply what you have learned in EMAth, right? So in EMAth, how do you solve for indices question? It's basically to identify what the common bases are. You're going to basically change all of them to the same base, and that's how you can solve it. Okay, and most of the time the base will be basically a prime number that is typically what all of them can change into. Okay. The first thing I want to do in question 1 is to basically remove the 5. I want to basically have my subject that has the unknown on the left side, and then the rest I will move it over to the right. So you move it to the right, the times will become a division, right? All right, then I have to make sure both sides becomes the same base. So that will mean that I need to make my 245 becomes a sorry, this should be 243, right? I want to make my 243 becomes a 3 base. I want to find out how much power of 3 that has to be done to make it becomes 243. So it turns out that I need to multiply 3 5 times. Just keep on times 3 in the calculator. And remember, this is EMAP, right? So it's always possible to change both sides to the same base, right? So once you have the base being the same on both sides, the next thing you're going to do is to compare the index. So remember, the index on the left must be equal to the right as well. So therefore, x is 5. All right, second question looks a little bit more complex, but the idea is the same. You want to try and make all the bases become the same. But of course, on the right side here for question B, the y can't really become the same base as 2 or 8, right? However, you know that anything power of 0 is always 1, isn't it? So that is what I have to do. I just need to change it to 1. But for the left-hand side, then I must find a common base. Now, and like I said, the common base is usually the smaller number that is a prime number. So since 2 is a prime number, we're going to check to see if 8 can become 2. Can it? 8 is made of 2 times 2 times 2, 3 times, right? So this means that if you change 8 to the base of 2, it will have 2 to the power of 3. But do not ignore the rest. The rest will still stay put over there together with the square root sign. I think in the previous video we haven't really shared about the what to do with the root, right? All right, so there's nothing to do for the second term, which is why I leave it the same. But whenever you have a square root, that means that you involve a fractional index. So as long as you do a cube root, for example, that means the denominator for the index is 3, right? So if let's say you do a square root, then you have a fractional index of the denominator of 2, just like that. So I'm going to distribute the 3 into both terms because again it involves a bracket, right? So for the index that has bracket, it means you have to multiply. So I will have a 6x minus 9. And if I also include the square root into the index, it's going to become a fraction of over 2, isn't it? And I don't want to put it in a single fraction because later on I might have to join some like terms together due to the fact that I need to combine with this, isn't it? So putting them in a single fraction might complicate things. So I want to divide them by 2 separately, which means that 6x divided by 2 as in like 3 times 2z, then because of the square root, we divide it by 2, right? We've got a 3z here. And then for the second term here, you've got a negative 3 times 3, which is 9, and divided by 2, which is 4. All right, once you have that with the same base, then you can join the two bases together by adding. Right? So same base multiply, one of the law indices state that you have to add the power. All right, which result in this. So you will join the z together, which has a 6z, and then the negative 4.5 plus 3 will result in a negative 1.5. Lastly, what I have to do is to change the 1 into a base of 2 again. Remember, it's all about making sure all the bases are the same. So this 1 is still not the same base, right? I change it into 2 to the power of 0. Remember, all powers of 0 will always result in a 1 as your answer. So once both sides have the same base, similar to what we do in A, then we can now compare the index, which means we say that 6z minus 1.5 is 0, and we solve for z. All right, so divide by 6 on both sides, it will result in 1/4. Right, right. Now, even though this is a sharing session, I am actually not using the answer key when I do the solutions with you. So if there is any mistakes, I hope you can be a checker and develop a strong ability to check for the work. I've seen a lot of students who can do pretty well in mathematics because they got strong concepts and knowledge. But what they fail to do well is basically they can't handle the accuracy portion, which means that they tend to make a lot of careless mistakes. Okay, so that's one problem factor that you have to consider. And when I tend to tell students that they make careless mistakes, right? What they normally do is they will just basically correction, they will cancel the whole thing and start all over again. But imagine if you face this in an examination, who will be there to tell you if you have made a mistake? So the most proper way to check is usually by going through the steps again one by one. Okay, so you check for whether you transfer things correctly, whether is there any calculation done that is wrong, right? So that's what you have to develop in terms of the practice wise checking. Now for the last one here, I have quite a couple of bases that is 3 except for 54. Now some of the students might think that you have to change 54 into 3 to the power of something, right? Because that was what I said earlier. However, you will find that 54 doesn't link to the base 3. The 3 power cannot become 54. So what is different as you compare this one to A and B is that firstly, you will already want the number that has an unknown as an index to be the subject, remember? So we are going to keep that, and we're going to move the rest over to the right side, okay? Which means that that right side will become a plus when you switch the opposite side to equal sign. Negative will become positive. Okay? So 54 plus 27, you will get 81. All right, and then after that, you will check again to see if 81 can become the same base as the left-hand side. You will realize that you can, because 81 is equal to 3 to the power of 4, right? Now, so again, we have successfully made both sides become the same base. And when you achieve that, that is the time to leave the index, saying that they are the same. Simplify this, you can leave it in a fraction so that we can avoid rounding off. And that's all. Hope it helps you. See you for the next one.